All right, the next thing we go to is carbon injection. So mercury is something that's just in the ground in tiny, tiny amounts. It's something that just exists out there in the world. So activated carbon, we got a silo, and then it's got 3 little cones on the bottom of it. Whew, that didn't line up. Activated carbon. So the carbon is something that has a lot of surface area to it, and it will bond with all the stuff that we don't want in the flue gas. Mercury is the one that there actually has a limit for, that is actually being controlled. But if there is lead, or there is iron, or whatever the hell else they dug up with the coal, that might get in the air, and that might be poisonous, this carbon is absorbing all of it. And that carbon blows into the flue gas, and then it kind of builds up on the sides of the bags, and that's where the actual reaction is mostly happening, is when the flue gas is getting pulled through the bags. So in the carbon silo, you've got 3 identical systems, which go to a rotary feeder, and then the rotary feeder goes to a little hopper, and then the hopper goes to a screw feeder, and then the screw feeder goes to a blower, and then the blower goes into the flue gas. Now on the 5th floor, you've got 6 nozzles on the north and 6 nozzles on the south. So you've got 2 headers, one north and one south, and these blowers can be lined up to those headers. And it only takes one of the 3 blowers to make our limit. And that is because we do something else to also control carbon.
Calcium bromide.
We add calcium bromide to the coal. I don't have anything drawn on here to add to. Calcium bromide gets sprayed on the coal when it's going up into the silos. And then that makes the carbon way more effective. I don't know the physics. I don't have an explanation for how that happens. But it used to be that to make our limit, we had to have 2 of these things running at 40% most of the time, 20 to 40%. And now we have one of them running at less than 10% most of the time. This mattered because carbon is expensive. One carbon truck costs like 5 times as much as one lime truck. Which is to say it costs like $30,000 versus $6,000. I haven't looked those numbers up since I was a control room operator. So like those are 2014 numbers.
That's what I heard, 25,000.
25,000 for a truck. So the hopper has like a low-level switch on it and a high-level switch on it. Whenever the high-level switch clears, it tells the rotary feeder to run, and it catches it and dumps it in. And that happens for, then once the high level comes back in, it runs for another 15 seconds or something, and then stops. And that keeps so you're batch filling that little hopper on top all the time. That low level switch comes in, and it shuts the blower down and the screw feeder down. And that is because
Control, we're done transferring vehicle.
when this whole system gets empty, then that stuff, it likes to flow like water. So when you try and refill the system for the first time, it's a pain in the ass because it's just going to want to flow straight through the whole system and go straight into the damn ductwork. So there's some procedure that has you taking a cap off and putting your hand on it and letting it fill up. And we don't want to have to do that. So when the bottom level comes in, then that shuts the whole thing down. The top level is used to tell the rotary feeder to start, The screw feeder changes speed to maintain your limit. So Mercury, 1.2 pounds per billion BTU. And over here it was a million BTU. So 1,000th as much. It's the limit is way tiny. And we normally run a 1.0 with that limit of 1.2. There's little rings of, there's like a air receiver, and there's things to fluidize to make sure this stuff keeps flowing, which seems kind of crazy because every time I've seen it, it's flowed awful damn good. There is a little vent on top of this hopper. Ah, it should be in pink.
The cap's always coming off
Little vent on top of that hopper. If everything's working right, you might feel a tiny bit of vacuum on it, you might feel nothing on it. When these nozzles get clogged, then this blower will start to blow back up into there, and carbon will start to spew out into the room, and then carbon will be 2 feet deep in the room, and then we gotta figure out how to clean it. By the way, everything it touches goes ultra, ultra black. It's no fun to clean. Back in the day, when you had to have 2 at 40% to maintain your limit, not only did it puff up a lot more because 40% clogs the nozzles way faster than 10% does, but also when you shut it down, you weren't able to make your limit anymore. So now there's this big hustle, oh, we gotta clean all the nozzles as fast as we can, and then we gotta get back in service. It's way more relaxed now than it used to be, thanks to the calcium bromide we put on the coal.